All right, ladies and gentlemen, welcome back once again to Ocean Motions. Last time we had class, we used this diagram here to talk about how the gravitational pull of the moon and inertia cause high and low tides. Well, today we're going to find out how the gravitational pull of the sun can affect high and low tides. It can affect how high the high tides are and how low the low tides are. There are two specific types of tides that we're going to talk about today. The first one is spring tides. These tides have nothing to do with the season of spring. In fact, they occur 2 times a month, no matter what time of year it is. They happen during the moon phases of full moon and new moon, and that happens when the sun, the moon, and the earth are basically in a straight line. During spring tides, high tides are especially high and low tides are especially low. This means that these are the times of the month when we see the greatest difference between high tide and low tide. Here's a diagram that hopefully will help show a little bit of how spring tide works. Here's the moon. Its gravitational force is pulling the waters of the earth in one direction. And here's the sun. Well, the sun is pulling the waters in the opposite direction. This causes really high tides. And if there's a really high tide, well, that water has to come from somewhere. So that means that the areas of low tide are even lower than usual. The next kind of tide that we're going to talk about is neap tide. Neap tides also happen twice a month when the moon and the sun pull at right angles to each other. So basically you have the sun, the moon, and the earth at right angles. This happens during the first quarter and the third quarter moon phases. And it's during these phases where we see the sun, the moon, and the earth at a right angle. During neap tides, high tides are not all that high, and low tides are really not all that low. There's not as much difference between high and low tide as there is most of the time. All right, here's a diagram here that shows a little bit of how the sun, the moon, and the earth are lined up during neap tide. Once again, here is the moon. Over here we have the sun. Now, as opposed to when we looked at spring tides, now they're pulling in different directions. They're kind of working against each other. The pull of the moon still causes high tides, but the pull of the sun doesn't allow those high tides to be quite as high as they might normally be. The last thing we're going to talk about today is the predictability of tides and also the power of tides. Well, we've talked in the last few days about the fact that scientists can actually predict the tides, the time of the tides, the height of the tides, things like that. And they can even create tide charts that can be used by sailors and by people of the public in order to decide on different activities that they might want to do. It's also interesting to note, however, that it takes a tremendous amount of energy to move tides in and out. That energy is potential energy, stored energy, that's just waiting to be used. For many years, scientists have been trying to figure out how to harness some of this energy. While they have not been quite as successful as they might like, they have developed some tidal power plants that capture some of the energy as the water of the tides moves in and out. However, this is only useful in places in the world where there is a difference between high tide and low tide of at least 4 meters. For example, we talked the other day about the Bay of Fundy in Nova Scotia, Canada, and the fact that they have very high tides that come with water that comes rushing into that area of the world. This is one area of the world, Nova Scotia, the Bay of Fundy, where they have been working to try to develop these tidal plants where they can harness some of the energy that it takes to move all of this water. However, not only is there the problem of you have to have an area in the world where there's a big difference between the high tide and low tide, in fact, a difference of at least 4 meters. But there have also been a lot of questions over the years about whether or not these tidal plants would end up doing a lot of damage to the environment and to the aquatic life that live in these areas. All right, well, ladies and gentlemen, you should have filled in your notes at this point. Your notes for tides should be complete. Please make sure that you put that into the notes section of your binder. And in just a moment, you're going to be reading an article that explains spring tides and neap tides just a little bit more. I hope that you guys have a really great rest of your day. All right, thanks guys. See you tomorrow.